This is my another episode of Memory Forensics. I hope you have enjoyed the first part of it, which was for malware analysis. Now, it's time for the second part. This gonna be a little longer session with lot of technical stuffs. So, can't go without coffee. You can follow the timeline posted in the description if you want to view any particular section. So, let's dive in. So guys, are you excited? So I am very much excited today because there are a lot of stuffs that we are going to cover today's discussion. So I hope you guys remember the previous discussion where we have detailed all the artifacts, how you can actually do the static analysis of WannaCry malware sample. So without doing any further delay, let me log into my forensics workstation and let me directly jump into the memory forensics that we are going to cover in this today's episode. Right, so this is my WannaCry memory image. I have captured it when I was infecting one of my VM machine with that malware, right? So I am really excited to do this right now. So there are a lot of things we are going to cover. So you need to pay attention each and every step that I am going to say right now. Okay, so let me fire up my console. Okay, so let me zoom in a little bit so it is easier to visible for you. Okay, and this is my WannaCry raw sample. Okay, so the first step while we launch any kind of or well, the first step that we need to identify what is the version of this particular raw image. If you are not familiar with the virtual machine or any infected machine as such, which got infected and you captured the raw file. So we will try a KDBG search now. So it's really simple. What we will do, we will simply vol.py and -f. So for this file information, so uh, this WannaCry.raw, and we need to identify what is the image info, right? So image info will give me what could be the file um artifact and what could be the possible uh, okay, my bad. So there is no dash dash, though it is not a plugin as such. So image info basically tells me what is the proper profile I can use, volatility, to tell that okay, this is a particular file and you can run it. So, okay, so maybe it will take some time, um, some minutes of time, and it will give me the result. So as you can see, it's already populating the result. So the best option which is in front of my, so let me highlight this for you guys, so that will be easier. Okay, so there are some profiles. This is one profile and this is another profile. So instantiate with this is also. So let's assume that first I will try to use that one, and the easy step to try with it to run demo plugins like PS3, PSCAN, any of it, and let's try if that works. So if it is not working, you will see a gibberish output. So that will not make any sense, right? So straight away we will do that, and let's see if that works for us. So I'm assuming that will work for us anyway. Okay, so what we will do, we will okay, so image file. Okay, so what is the next step? Next step will be minus minus profile. Okay, so and we are choosing this profile to start with. Okay, so I'm copying it and pasting it, paste, and I will try ps list. If it works, that means our profile is correct. So as you can see, it is running properly. Okay, so now we are into the investigation mode. Okay, So the first step, when we ran PS list, it is giving me the current running process at the same time when the machine was infected and when we captured the memory dump. Okay. If you notice here, there are a lot of stops going on, and which specifically things that catching my eyes. There are some lot of HPC hosts are there. There are LSAS processes there. There are other things as well. But the things that is catching my eyes is this one, a decryptor, right? So this is running. This has a PID, which is process ID of 740, and just notice it has a parent process ID on 1940. And if you go in this line and if you just check what is 1940, it is a task scheduler.exe, which has 1940 as a parent process, sorry, as a process ID, my bad, and it has a parent process of 1636. Okay, so I'm not pretty much concerned about this one. So, and if you see, it started at this time and this one started at this time. That means task scheduler.exe being the parent process of one decryptor, this exe and the process, this starts first and this probably has started this file, right? So these two things is suspicious, and you can note down this memory address space as well, that we can use in latter point of time in our investigation. Okay, so now we know what needs to be targeted, right? Okay, so the next phase, let me clear up my screen here. Okay, so the next step, PS3 will give me the output of the process which is present right now in the memory when my capture was done. But there is another plugin which is called PSCAN, right? So that PSCAN will give me all the files and all the processes in the memory when the time that has got exited, right? So now if you here again, if you need to notice, so there are a lot of there are three main columns here. Okay, so again, let me highlight those as well. So if you notice here, these process IDs are our point of consideration. Now task dl.exe, interesting, this we didn't observe in our previous one. And task ac.exe, this is also a new thing. So if you see, these processes got already existed, so that means this process got terminated, and one decryptor.exe was there in our previous PS3. um, and this is also interesting stuff. This anyway we know, SVC host DST and one decryptor.exe as well. So if you notice here, there are a lot of things, and we really we can understand and we can build our timeline. What is the entry point of that this first exe? Then probably this is coming with this exe, and next probably this task scheduler.exe is calling up this one, right? So we can map down that and we can identify what is actually going on in the system. And if you notice here, so the process ID of one decryptor again is 740, and it is originated for 1940, which is nothing but our um, sorry, not this one. So 1940, it happens to be, let me go back to the previous one, uh, 1940, right? So yeah, task scheduler.exe, right? So task scheduler.exe is the parent process of one decryptor.exe. So that is interesting. So we now know what process was created in the memory, what process got exited from the memory, right? So now you can drill down into further level. If you just simply do a PS scan, then you just simply do a grep on that particular 1940. So that was our initial identification. So you see that uh, all these processes is originated from this task scheduler. Okay, so this task scheduler, by the way, is still existing in the memory because this doesn't have anything which can say me that okay, time exited. So this process is still exited in the memory. This has called this one, and all these processes are child process of this thing, task scheduler.exe. So that is the reason we can see all this has the same parent process ID. Okay, pretty much interesting, isn't it? I am amazed. Okay, so lot of stuff. Now, the thing that you can do the same, and you can do the same check by just greping 740. You remember what is 740? WANA decryptor. So there is only one WANA decryptor file with 740. So from now onwards, our whole investigation will hover around these two processes because WANA decryptor has 740, which we assume that this is the main culprit of machine encryption or whatever process is going at the back end, right? So, and we will also focus on this 1940, right, which is our task scheduler one, which is our parent process and which got triggered at first. Okay. Now, next step will give me that what are the DLLs has been called by this process. Okay. Okay. So anyway, I have done a mistake. So that I need to mention the process ID here. So that is the reason -P for process ID and 1940 is for the process. Okay. So that will give me the DLL list of that particular process. Okay. And now if you notice here, this task scheduler is the process and this is running from C Intel this location. This looks interesting, right? So now at some point you may also do some kind of testing that there could be some other files also present in that particular location apart from this task scheduler. So that we will see in next in a minute. So what are the other files that could be present in this in this particular location? But we know that okay, this is a location where this task scheduler was present. Now if you go back to that infected machine, if that is still present, and you can hover around, and if you want to capture that sample image or sample dump of that process, you can do that. But anyway, since this process is still in the memory, we can extract that from his locations or from his base location. So that we will see in a minute how you can dump that process out of its memory. Okay, so next thing what we will do, we will run the same exercise for the other process, which was 740. Okay, so that was our WANA decryptor one. So let's see. And interestingly, if you notice here, it also has the same path where its parent process was talking to. So if I just highlight, so if you see here, okay, my bad, so it's a big one. So okay, so WANA decryptor is running from the same path, okay, where is parent process was loaded. So now you got that intuition that there could be some other files also. Okay, we will see that in a minute. Now let me focus on some other parts as well. What is this particular process 740, that is WANA decryptor, is actually accessing? So by which you can understand that okay, what could be its mode of agenda and what it's actually trying to do now. Okay, if you focus here, there are some files, right? So if you see here, there are like this one. This is interesting. You know what this particular thing does? So this particular thing where this particular thing is used basically to query registry. That means WANA decryptor is querying the registry as well. secure32.dll. So this is also really interesting. So whenever you are doing something like with with a secure shell process, and if you know there are some other secure shell that you need to communicate with, generally you go to that DLL and ask your system that okay, I need access to that particular shell command, shell.dll link library. There are also something like which calls my ISO urlmon.dll. So why a process need to access urlmon? So urlmon.dll is if you just Google, it will with the general browsers accept, right? So the browser could be present in any of my machine, like older machine of Windows 7, like Internet Explorer kind of stuff. So that means my WANA decryptor is also accessing URL mon. That means it will load up some strings into memory which will communicate with the internet. Okay, so this is also interesting. And if you come here and if you check, so there are some other things as well. So anyway, kernel.32.dll, so it keeps on loading in everything. So and if you focus, there are okay. So OLE32 is also interesting. So we can identify by something that so the high level network communication is happening because we see the winet.dll. So where is it? I believe it should be there. Yes. So this one. This DLL is also represents some network communication protocol. So that particular DLL is used for that. So now we know WANADecryptor.exe is loading from this location and it is accessing a lot of DLLs, which is responsible for doing many stuffs. Okay, now you can evaluate that. Okay, so what could be the mode of operandi of this particular process and what is it actually doing. So now really interesting stuff we need to understand that. For till now we identified there are some process going on, the process is accessing some portions of its DLL, but we haven't identified any of thing that if you go back and if you check it. So let me run my PS scan again. Okay, let me run it. So, okay, so if you notice here, so there are like one a decryptor file which has a parent process of 424, and the one a decryptor process that we are working on is having another process ID, so which is 740. So now, so just let me cover up this and let me highlight this one. So 740 is first one, and we have another one which has 424. Now, one got exited from memory, one is still in the memory. So that is the reason I do not have any time exited format. Now, interesting stuff, if we need to know that, okay, then which one a decryptor process is actually running in my memory and what is its actual mode of operandi. In that case, you need to go and check what could be the handles that this process have created. So there are a lot of plugins and keyword strokes is present in volatility which can help us to identify what is handles and what is other stuffs going on. So first handle and first match that we'll do, that's called key matching. Okay, so let me try out. So let me clear up the screen first so it is visible well enough for you guys. So we will try out the handles now. So the first handle that we want to try out is for obviously for key. So that means we want to identify if there is anything like any user identity or anything that particular process has taken into custody. So as we see, there are offset level obviously present here, and this user is looking appears to be a system user, and this process is talking and taking a reference of this user. So that means this process automatically becomes a privileged one. So that is the reason it can do anything on the machine. So that is interesting. So that is our IOC. So next thing we will need to check that if the process has created any mutant on that box, and that is the reason it might have been overpassed or might have been bypassed any kind of every identification or something, right? So let's try out that. Okay, interesting. So now if you focus here, so you will see that there are two particular mutex that has been created by this process. So easily understandable that my mutex is this is one mutex A0, and this is second one, and this is sim cache mutex also created. So interesting. So now we can identify that this particular process was loading from memory, and this particular process is creating mutex to maintain some kind of persistence, but this is not actually a persistence mechanism, but this is a bypass mechanism. Due to the reason it tends to create some mutex and loads up other stuffs, right? So that is the reason it keeps on creating mutex and other stuffs into the memory, and other things keeps on happening. So if we do the same check for the other process, which is my 740, first let me check the key 740. I am assuming it will also have used the same privilege of its parent process. Okay, really interesting. So now if you see the same user, same 1003 user and this 1003 user, these are system users basically is getting executed, and if you just see here the path of the software, Microsoft Windows NT current versions and Windows, right? So that means my one decryptor process is also a privileged one. So parent process is a privileged one and my child process is a privileged one. So obviously it has a correlation, and that is the reason it can use any of the resource of your machine, and it can bypass anything, it can stop any process, it can do anything it wants, and it's creating mutex. So let me check and let me try to find out if this process has a mutex as well. Okay, so this doesn't have any mutex. So now and obviously, right, so there are like not necessarily that your child process has to create a mutex as well. So you know that the parent child relation is established via the system privileged user, right, and your parent process is having a mutex. So that means you do not need to create another mutex for your child process. So that doesn't really make sense, right? So now, for now, we do not have we haven't actually identified anything which gives me a persistence mechanism. Right now there are something by which you can identify a persistence mechanism, and there is a uh, plugin in volatility which is used basically for this purpose. It's called print key. So what print key does, and we will try to load up the, and we will try to scan up the run key, run once key, and if you are doing malware analysis and memory, so and you know how persistence mechanism works. So basic malware technique is a old school malware technique that it tends to do some modification, and it tends to load up its process leads and other mutex, drops it in the run process. Okay, so that is the reason it keeps on coming back again and again if you delete the machine, and if you delete it, the virus infection as well. Okay, so let's try out now. So what we will do, we will try out something called print key. Okay, so print key, then space k. K is for the printing and the from which location you want to identify. So the first location that we want to identify is Microsoft. I hope, okay, Microsoft. Then it's Windows. Then it's called current version and run. Okay, so I'm hoping it will work. Okay, so it's currently searching from my and what are the things that is getting executed. And if you see here, this is really interesting. So this location, if you remember, two step back, if you go back two step, so our task scheduler was present in this location, and even you can see the location as well, right? So this is our parent process, and this is our mode of injection for everything from every cycle. And to start with the every cycle, this process was loading first, and this process is noted in the run key. That is my persistent mechanism. So you can do the same check for run once as well. So I'm assuming, let me see if there is something, anything like anything present in run once. Let's see. So, okay, run once, okay, it doesn't have anything related to that. Okay, so that's cool. But we know like run key has been injected with this task scheduler process, and that is my, I know how the persistence mechanism right now is working on the machine, right? So what else we can do? Now you identified what is the rogue process, what is the entry point of the machine, what is the child process it's executing, what are the files by which it was called, what are the DLLs that it covers. You know the persistence mechanism as well. Now we will try to load up some files, and we will try to check that if in this location, if there is any other file which was present from our previous string operation and which was present in our previous episode, and we can try to identify something, because that was also our intention, right? The strings, obviously we have identified this task scheduler and this wanna decryptor strings in our previous episode. There are some other files also present, right? So now let us directly go back and let us try to check. So let me copy this location first, okay, and let me clear up the screen. And what I will do now, I will run another module which is called file scan. What this file scan will do, it will scan through my memory and let me grep out this particular location. Lot of things, right? So when you are doing memory investigation and like loads of stuff, and interestingly, you see there are a lot of things coming up. So really interesting stuff. So now you can see like these are the files. These are the message files. Okay, so obviously from the location and the language specific message files is present in my this particular memory location. You can dump each and every file as well. So as you see, there are one decryptor exe file present. Okay, task scheduler exe present, u dot WannaCry present, T dot WannaCry present, C dot WannaCry present, and there are some message file in other language, English, Swedish, Vietnam, Slovak, Spanish, Russian, Turkish, a lot of things. Okay, so we are really lucky to identify that all of the files that we identified from the string match is present in the same location. Now we can do some other testing, like we can identify these files and we can dump this file. Even we will do something like similar right now to identify, like if we do a string analysis of this file, if you can identify something else. Okay, so let's do that right away. Okay, so let me create a folder here and I'll call it dump files. Okay, now let me go back here, and what I will do, so there okay, so first, my first priority is to dump file from this memory address. Let me copy it up as well. Okay, so what I can do, there is a plugin called dump files. Okay, -q is for my memory address location. I'll specify this. -d is for dumping. So that means I am asking, okay, I guess dump files. Okay, I hope it works. First, let us check. Okay, none is it created? Let me go back to my location. Okay, so interesting. So my this file has been dumped from my memory. So now you can do the same exercise for these c.wannacry files and other files as well, right? t.wannacry and c.wannacry as well. So similar process. You just need to grab the memory location and offset location, and you just simply dump it using that. Okay. So what we will do now, let us do some, if we do a LL, let me clear up the screen and do a LL, and I go to dump files. Okay. So there is a, so I am assuming this is my dump files. Okay. So let me check it out. What is this file called? Okay. File none. FED. Okay. You see, it's a P executable file. That means this is my wanna decryptor sample file that I just dumped from my memory. So we have seen a lot of strings are there in the particular file, but we really don't know. So what could be the interesting stuff going on in the machine? So for that, we need to do a deep dive of static analysis. I am not going through that, but for just for an instance and to identify, we know that we have seen in our previous episode that this one decryptor was responsible for deleting some of my shadow files, right? So that is the reason I am just trying to grep something out of my this file. So, and as you can see, it is deleting all my shadow, and it is doing it with a quite string, and it's calling WMIC to delete the shadow files as well from the bootload extractor as well. So that means you know what the things that is going on into your machine, right? So you can do a deep dive analysis on static behavior of that particular wanna decryptor file using string match, using P Studio, like the way that I have seen in my previous episode. So I'll post the link in the description box below, and you can see that it's coming in my screen right now as well. So you can get the help from out of it. Okay, so a lot of things I have showed you already. So are you feeling like okay? So a lot of stuff is going on. So let's hold the thing for a bit and let us take a coffee break or something. So just to release the pressure and what are the things that is going on. Okay. So, interestingly, something else also I want to share that in my YouTube journey. So, lot of people and lot of viewers I'm getting. So, lot of love from you guys. So, really helping me to build up my community and build up my channel. So, thanks a lot for that. So, nothing is possible without your support. So, if you feel any time that either I am going too fast or there is any other feedback, feel free to share in the comment section. So I'll be happy to incorporate that in my next episode as well. And one thing also I need to share that TubeBuddy is also helping a lot the new creators like me in our new journey. So this video is not sponsored by TubeBuddy or anything, but there is an affiliated link that you can find in the description box. And if you are thinking to start your YouTube journey, I would suggest that you definitely go and download the TubeBuddy. It's an awesome tool, and if you use my download link, you will get a discount as well. And by doing that, my channel gets a little bit of help from you as well. So okay. So, okay, so that's all. Enough other talking. Let's get back to the business. Okay, let me try out another plugin. Okay, first let me try out the PS list and let me see what are the other things that I can dump from memory. Okay, so one thing is interesting that I want to definitely dump this. Task scheduler process. Okay, so my task scheduler process is residing here, and this is 1940, and obviously this one also I can dump. Okay, so let me do that. So for doing that, what is the plugin that I will use? That is called memdump. Okay, memdump is used to carve out the process or anything from directly from memory, like the way we have seen the dump files. Okay, so for doing that, what I will do, I will simply mention the process IDs 1940 and 740, that is the child process, and for minus D's for dumping, and I will say dump it here simply. Okay. So by doing that, we can do a simple string analysis of my both of the files. Okay, so as you see, first process is getting dump in 1940.dump, and obviously the second process will also be again you can see 740.dump. So this current thing is currently dumping my files from memory space. Okay, if you do a ll, if you see both files is present now from my location. Okay, so the same command that I am going to run, which is a string, and I will use that 740.dump, and this time I just want to see what are the head files. So let me do a head also, maybe 100 lines. Okay, so okay, interesting. So okay, now let's go back and now let's check it out. What is the thing that is doing? So if you come here and let me highlight that as well again. So that's the best thing. Uh, okay, okay. So check payment, and this is a new string. Okay. So probably this is my Bitcoin location address or my wallet. Okay, this I can check out in Google. We will do that in a bit. I can see one onion IP address, another onion IP address, another onion not IP address domain, another onion domain as well. And I can see Tor project is getting loaded as well. Okay, and one a decryptor process is there. There are something which is going on here. So if you focus here, um, it is calling the file from the same location. It is a high contrast file and it is a loading arbitrary string. So my main thing and my main mode of operandi and I identified so far, we got the Bitcoin wallet address, we got the onion router address. So by doing that, you can gather more IOCs like this one. Okay, let me try out something. If I can try to find anything like grep, maybe CMD. Okay, so cmd.exe is starting my WannaCry decryptor process. So that is the interesting stuff. That means now we know how WannaCry decryptor has been called by my parent process. Okay. CMD process is obviously residing in system 32, nothing fascinated about that. And if you come here and if you see this cmd.exe, this is a regex pattern that has been passed from the memory, and that is the instruction given to cmd.exe to load up wannacry-decryptor.exe. Okay, so the last thing from today's episode, let me show you how you can use some other plugins to build up your timeline as well, how the incident occurs in the memory and what went wrong and what went good. Okay, so what we will do now, not this one. Okay, so I will use another plugin called Timeliner plugin, and I will do a output file, and I want to save it as timeline.txt output equal to body. Okay, this timeliner plugin will scan your memory and will uh, do a deep dive and will scan all of your process and you will create everything in timeline.exe. There are other two process that we will be using again. So one process is called MFT parser and another process is also there which is called like shellback. So shellback analysis is not in the scope of this investigation. We will do that in our later point of time. And after you have run all of your timeline plugins and everything, you can merge your three timelines in a super timeline. Okay, and while you want to present your forensic investigation report to other people and maybe your management or maybe anything, so you can draw a suitable file format using vStudio, using GraphiViz, or using a simple tool also you can use, right? So we will show you how you can do that in our coming episode, and we will discuss about super timeline and other timelines and what is the suitable way that you can build up your timeline. Is there any like tool available in the market that we are going to discuss? Okay, so meanwhile we come back here and okay, no shim cache data found. Okay, fine, so I don't really care, but let me check if anything like created. So timeline.exe has been created. Okay, next thing what I will do, let me use the another plugin. So that is called uh, MFT parser. Okay, and I will write it into MFT parser. Okay, maybe it will take another maybe 1 or 2 minutes. So it will scan your MFT entries in the system, it will build the directories, and it will load off your every output in the memory as well. Okay, so as you can see here, my MFT parser scanning is complete. Let me check. So okay, MFT parser text also been created. Now the last step of this one, which we will call like shellback. Okay, so let me clear up the screen here. Okay, and I will use the shellback. Let me first change the output file name and let me change the parser as well. So which is called shell bags. Okay, so again it will take like a minute or so depending on your all shellback items and building your path tree and everything. So shellback forensics is a deep scope and we will try to come up and cover up those things in our coming episode. So let's see what are the three files and we can get out of it, and what are the beneficial thing that you can do. Okay, so shellbag is also created now. Okay, so I have all of my three files timeline created. So these are differentiate timelines. So now what we will do, we will simply do a cat and I will use like timeline.text. I will dump it in super timeline.txt. Okay, this is done. Now I will do a cat and I will use my shell bag. So okay, so next thing, let's do a MFT parser and I will append it in my super timeline.text. Done. And the last step that also I want to do, I want to append the shellback output as well in my super timeline.text. Okay, so if you come here and if you see here, your super timeline.text has been created now. Okay, now all three files have been created and my super timeline is also created. So if you now check the super timeline, it will be like a file format which doesn't have any timestamp. Okay, so there is a process by which you can identify. So if you do a like mac time, you can get the help information as well. So mac time is used to convert your any file format or anything in related and attached it with a timestamp format. and it uses -z to specify the time zone. Okay, so let us understand, or let us see that I want to do something like I want to convert in everything in GMT. Okay, so let me check out that -z GMT. Okay, so I guess it won't work. So okay, so first let us try out like anything like GMT, anything or anything happens, or if anything similar like is present in the system. So you can identify by using GMT list that we will give all of the time format that is present in the machine, and you can simply grep it out. So let me grep like I want to convert it with GMT, so I can use the simply GMT format, right? So what I will do now, so let me simply do a mac time -b is for file, so I will use the super timeline format, and -d I want to do a separation as a comma, so simple comma separated value, -z, then I will space as GMT, and let me see if that is working or not, minus in 10. Okay, so as you can see, this is working at some point. So everything is taken care of to GMT format. So you can use that for using, or you can really identify what is going on. So now, if you do, let me see if GMT. So I hope there was a GMT plus 0 also available. Let me see if that works. Okay, that is not working. Okay, so let us, for this example, we will use GMT only. So you can buy, you can do UTC as well, I guess. Okay, UTC as well you can do. So, okay, so what we will do now, you can clear up the screen, and you can uh, do the same thing. And what I will do, I will try to simply egrep the file format that I want to work with and I want to load with. So for this example, I will take simply task scheduler, one decryptor, and task other files. Okay, so what is my event of interest? And if I check here, so it loads me all of the file formats is present, and you can see that these files are created with the timeline format. Okay, so if you go back and if you simply scroll up a little bit, so you can identify that. So when this one decryptor was processed, when this task scheduler came into the machine, and then whatever the process and how this process is actually worked and what happened afterward, you can get everything in your timeline. Okay, guys, so this is it from this particular episode. So I hope you learned something, then you learned how actually you can propagate and how you can actually use memory forensic skills and techniques to deep down malware investigation and prepare your plan for the next big event as such. So I hope, and I really hope that WannaCry or related site, like any could be like ransomware infection, never comes to your organization, and you shouldn't be in a position that you want to, and you need to handle a situation like that. But not only with ransomware, but to identify or to work with any related stuffs or any related malware, it's very important that you understand the basic core knowledge of it. Okay, either it could be anything, like you can do a like static analysis, you can do a dynamic analysis, and you capture a memory, and if you want to know what are the TTPs of that malware, how that malware is executing, it's very important that you understand the deep skills of volatility, and you parse and you utilize those skills to build up your IOC list, and again to deep down that you can prepare your plan of action, what you need to do to mitigate that from your organization, or to remove that for your future incidents as well. Okay, so please let us know and how you feel about this particular session in the comment, and if you have anything like any feedback for me, and if you want to see me coming with some particular topic, feel free to post that in the comment. And if you have any query related to volatility, and if you need any support, identification, or do some practice of your own how you can do a malware investigation, please let me know in the comment section below. I'll be really happy to help. And meanwhile, please check my other tutorials what I have been posted in YouTube related to malware forensics and related to memory forensics as well. So you can see that currently coming in the screen. And in future scopes, I will be really trying to develop some new other techniques as well. So we will deep down something like shellback forensics. Maybe we can do some like Windows code forensics, like other tools, and we can explore some new tools. There are a lot of tools currently in the market, so we can explore all of the tools. Okay, so stay tuned for all of the things to come. There are a lot of things to cover for me through this channel, and please don't forget to subscribe if you like this content, and please don't forget to drop a like so that I get more views and I get more encouraged from your participation and your engagement. Okay, so thanks for watching.